All right, let's get right into this. I want you to imagine building a really complex piece of software. You know, the kind that people actually use every day, but with one massive radical rule. No human is allowed to write a single line of code. That was the wild experiment a team at OpenAI ran. And believe me, it completely rethinks what it means to build software. And I mean, this was the #1 rule, non-negotiable. For 5 whole months, they built a real product. It ships, it deploys, it breaks, and it gets fixed, all without a single human ever touching the code. Every single line, from the main application to the documentation, had to be written by an AI. And look, we're not talking about some little hello world script here. After those 5 months, the project had around 1 million lines of code. This wasn't just code for the sake of it. This was a real, functioning product with daily users inside the company, all built by their AI agent, Codex. So the big question is, how on earth is that even possible, right? How do you actually guide an AI to build something that complex from scratch without it just turning into a complete, tangled mess? Well, that's the core mystery we're going to unpack right now. The answer really starts with this totally new way of thinking. See, it's not about replacing engineers, it's about changing the job description entirely. The new mantra is super simple. Humans steer and AI agents execute. The human's role shifts from being the builder to being the architect, the guide. A new role like this needed a new name, and they came up with harness engineering. And what's so interesting here is the focus. It's not about writing code anymore. It's all about designing the environment where the AI works. It's about being crystal clear about what you want, your intent, and then, crucially, building feedback loops so the agent can learn and fix its own mistakes. Just think about the difference for a second. A traditional engineer, they write code, they hunt down bugs, they build features directly. But a harness engineer? Totally different ballgame. They design the systems the AI lives in, they build the tools so the agent can fix its own bugs, and they specify goals at a super high level. It's a massive shift in thinking. So you might be wondering, okay, that sounds cool, but does it actually work? Well, the numbers are pretty staggering. The team figured they built the whole thing in about 1/10 of the time it would have taken to write by hand. And with just a small team, they were averaging 3.5 pull requests, that's basically new code submissions, per engineer, every single day. That's an insane velocity. Okay, so let's get into the nitty-gritty. How did they actually do it? Because you can't just point an AI at an empty folder and say, go build a 1,000,000-line application. The first huge problem they had to solve was context. How do you give the AI all the knowledge it needs without just completely overwhelming it? Their first shot at this was exactly what you'd probably try. They tried to create one giant instruction file, a single document that explained everything. And yeah, it was a total disaster. This 1,000-page manual was so big it crowded out the actual task, it was out of date pretty much instantly, and it was impossible to even check if it was right. So what they realized is you don't give the AI a manual, you give it a map. That main instruction file became a short, simple table of contents. It just pointed the agent to a well-organized documentation folder, which was treated as the one and only source of truth. This meant the agent could learn what it needed, when it needed it, kind of like a human would. And to make sure that map stayed accurate, they had other AI agents constantly gardening the docs to keep them fresh. But a map isn't enough, right? To prevent total chaos and make sure the quality stays high, an AI agent, just like any human teammate, has to follow the rules. And that meant creating a super structured, predictable environment for it to work in. They did this by enforcing this really rigid architectural model. Every single part of the app was broken down into these fixed layers, and data could only flow in one direction, from the bottom all the way to the top, to the UI. No shortcuts, no exceptions. This kind of strict structure is something AIs are amazing at following. It stops the code base from turning into spaghetti. And listen, these aren't just suggestions written on a wiki page somewhere that everyone ignores. No, these rules are enforced mechanically. The team actually had the AI itself write custom linters, which are tools that automatically check code, and tests that run all the time. If an agent tries to write code that breaks the architecture, the system just fails the build. It's a hard stop. This quote from their write-up just nails the whole philosophy. The job of the human, the harness engineer, is to define and enforce those core principles, the invariants, but not to micromanage how the agent actually gets the job done inside those boundaries. It gives you this perfect balance of speed and stability. So what happens when you get this whole system humming along? Well, you start to unlock these incredible levels of autonomy. But Like with any powerful new tech, you also create brand new kinds of problems you have to solve. I mean, just look at this workflow. The agent could handle an entire bug fix cycle all by itself. It gets a bug report, records a video showing the bug happening, writes the code to fix it, records another video proving the fix works, and then handles the whole code review and merge process on its own. That is a mind-blowing level of autonomy. But all that autonomy created a new problem, one they call AI slop. Here's the thing. Since the agent learns from the code that's already there, it has a tendency to copy patterns it sees, even the messy or bad ones. And over time, this causes the overall quality of the code to slowly drift and get worse. Their solution for this is, honestly, it's brilliant. They basically invented garbage collection, but for technical debt. They defined a set of golden principles for what great code should look like. Then they created these automated AI jobs that are always running, constantly scanning the codebase for any of that slop. And when they find it, they automatically create a fix, paying down that technical debt bit by bit, all the time. So let's zoom out. What does this all really mean for the future of how we build software? What's the biggest lesson we can take from this whole experiment? For me, this is the key takeaway. In a world where AI is writing the code, the real engineering discipline isn't in the code itself anymore. It's in the scaffolding around the code. The environments, the feedback loops, the rules, and all the automated systems that guide the AI to do good, reliable work. This really means the skills that are going to matter going forward are changing. It's less about knowing the specific syntax of a programming language and way more about being a systems thinker. Can you design a good environment? Can you build effective feedback loops and control systems? And maybe the most important one, how do you take human taste and good judgment and encode it into a system so that its value grows and compounds over time? Which leaves us with this one final kind of mind-bending thought. If our job is no longer to write the code, but to design the systems, the rules, and the knowledge that allows an AI to write the code, then is the future of engineering actually about designing the engineer itself? Definitely something to think about.